Okay, the list. So we talked about vector. Now we're going to talk about list. It's a linked list. Hey, watch this. I'm going to go fix this real quick. I call it vector fun, because who doesn't like having fun with vectors? I'll go down here and I'll call it vector fun. And I'll just make sure that still compiles and runs so I didn't mess anything up. Great. Hey, let's go change this to list fun. Oh, we can't call print vec. We have to call print list. I'll still call it vec. Okay, we'll change it from vec. No, we'll leave it vec. Sure, why not? Guess that'll still work. Alright, so we have drain, list, passing in list. We're just calling it vector up there because we're lazy. List fun. Alright, we should change this to a list. Yep, that one's good. Yep, 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 yep. Yeah, 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 yeah. Yes, 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 yes. Ooh, I don't know if list has capacity. Does that make any sense? That doesn't make any sense. Alright. Anyone think this will work the first time?
No. No way.
I think it's going to mainly complain towards the
Alright.
function.
Oh!
Oh!
Oh! Okay. Did it turn off the exact same thing as well? Except capacity, right? Yeah.
Size is, oh yeah, size is supposed to be.
Yep, size is still the same. Alright, well let me push this along a little further. I'm going to change it from print vec to print I don't want to spell it container. Ooh, will it let me do auto? I don't know if it will. Alright, we gotta template it. Actually, could we do start or could we just do the thing? Ooh, let's just do the container. I think that's it. And then can I go down here and just do print container? Let's see if it blows up in my face. Oh, it liked it. So let's go take print list, print container, and then we get rid of print list. Alright, I did that really, really fast. Y'all see what I did? Alright, the other cool thing is now print vec. I can change this to just print container because it is the same thing. And it would work. And I could delete print vec. I'm going to leave print vec in there, so if you want to review it, you can. But yeah, we could go in and change everything to print container, and now we have just one. We can do the same thing with drain list, drain container, and we do the same thing. Why is this incredibly handy? Well, hopefully OP made this clear, but just in case. This will, when you code it against the iterators and other paradigms, it means if you need to just change out your data structure, it's very easy to do so. You just change the definition, where it's defined, up here from vector to list, and then it'll compile and run. All right, let's go and look through it. Created a list, printed, could pop the back, push the back. I printed the beginning and I printed the end. I could call find for each as well as find on it. I could drain the list and then ask for the size. Capacity, we'll go ahead and show you that it's going to just explain, what even is. So, yeah, a list does not have all the same functions, but it does have a good number of them. Container or capacity just does not make sense. All right. Pushback. All right, so the list does have an extra feature where you can push to the front. All right, what comes before 42? I'm gonna let you type this. Ooh. Oh yeah, you just push it one at a time. And then print it afterwards? Oh, print underscore con is what I called it. So I did not append the class. Yeah. List. There we go. All right. Let's see if that 42 pops up now. By that I mean negative 42. Okay. Yep, there's the negative 42. Perfect. Okay. Oh yeah, L dot insert. Okay. Yeah, let's do that. And this is where I'm going to load up Firefox because I don't remember. C++ list. June has a desert. The brain is empty. Oh.
June has a desert?
What? Haven't seen that movie. Oh, I saw the 80s one, of course. Although there were multiple of them. I saw the first one from the 80s. The Spies. That's all I remember. All right, what was I doing? Insert. Here, insert elements.
Plural.
Oh, yes. Well, since this is C++, every function has multiple definitions. You can pick which one you want. We're going to do the simple one where we give it the position and then we're going to pass the value that we want to pass to it. That's what I thought it did. Hey, where can we find it? Oh, hey, look, we have some find. Well, let's just copy and paste this down. We'll do insert. So we're going to find whoever that 71 is. And by this one is a member of the function. So we could do list.insert. And we'll pass in 55. And then let's go ahead and print the container afterwards. Okay. Where's the 55 going? I don't recall either. What's that?
Maybe after 71.
It's either after or before, I don't remember. It's after. Nice. Hey, it showed up twice. Oh yeah, I printed it up during the drain. So there you go. Oh, no, I'm sorry. I was right. The 55 came before the 71, and then it was printed in reverse afterwards, so then it came after. So it comes before. So you're inserting before that iteration. All right, sure. Okay. And since it's a linked list, yes.
I just want to ask this about insert.
Mm-hmm.
Does it only really work if the list is in order?
No. The list we just did was not in order. In our example. Negative 42, 42, 51. Oh, it is in order. Wow. Let's go fix that real quick. Now it's not in order. No, it does. Because the insert just takes the iterator, which is a pointer, to where it's
Pointer-like, right?
Yeah, what's that?
It's pointer-like.
It's a pointer, yeah. Oh, I'm sorry. People online, I did air quotes when I said pointer. A pointer-like structure that behaves like a pointer? Yeah, sure, whatever. And then it inserts it there. So with a linked list, it's an O of 1 operation. If you were to do this on a vector, it would be an O of N operation because it'd have to move it over, although the code would be the same. If vector has insert. I forgot if it does. All right, so insert iterators. Hey, we've already talked about this. And this is why the auto thing becomes very handy. Oh, no, because you can still do an iterator of a vector, of a list. All right, never mind, we're good. Ignore what I just said, because we're okay there. Oh, you can copy the contents over. Yes, so there's the copy algorithm. Notice what this one's doing. You're passing in the beginning and the end, and then you're passing another list, and it's going to overwrite the elements. Let's look at this real quick. 1, 3, 5, 7, 9, and now it's even 2, 4, 6, 8, 10. So when you pass in copy from this beginning and to this end, starting here, it overwrote the elements with 1, 3, 5, 7, 9. Everybody got that? If you wanted to get super fancy, you could tell it how to insert it. All right, list 1 is 1, 3, again the odds. List 2 is the evens. Copy 1 here, but we're doing the back inserter, which means that's going to insert it in the back. So starting, aka it's going to append it. Here you do the front inserter, aka it's going to prepend it, but notice it did in reverse because you're doing it one at a time. And then what's this, the inserter? Adds contents at the old beginning of L2. Oh, okay, sure. So this one actually prepends it, I should say. This one inserts it in reverse order on the front. Yeah, that's great. By the way, you are free to implement your own inserter function if you want to. Things I don't see very often. That. Oh, good, sort and merge. Luckily, list and array all have a sort function. Bet you wish you had that. All right, so we're going to insert, print, and now we're going to do calling sort. List.sort. And then we'll print it afterwards. Calling sort, and now it's sorted. All right, linked list. Take a guess what they use.
Lots of pointers.
Lots of point. Which sorting algorithm?
Merge sort.
Merge, yeah. Which one do you think they use for vector?
Quick sort.
Do you care when you're using the data structure? Not really? Not in particular? But
Essentially auto-do the fastest what algorithm is what.
Right, so it is important to keep in mind that they're just choosing the one that they believe is the most efficient in general. So quick sort for an array in general is the fastest, although actually last year a faster one finally came out. After all these years, decades, like half a century I think, of quick sort, they finally came out with another one, which is really just a faster version of quick sort. But anyways, they're just going to call that function. It's important to keep that in mind because if that you don't, or it's important to keep in mind that they're choosing a general purpose algorithm. So if that one or sort behaves a way you don't like, then you will have to implement it yourself. But in general, just call sort, and if everyone's happy, who cares? Oh, by the way, you can also do merge, which will merge two lists together, just like you were doing a merge sort. Function objects, all right. So, did y'all do functors in OOP? All right, so notice how we've been doing function pointers, and we pass the function pointer to our function to call it. We've already done this a little bit here, because if we're up here in for each, we give the beginning iterator, the iterator to the beginning, iterator to the end, aka one after last, and then we pass a pointer to a function of what to call. You may also create what's called a functor, which is effectively an object that contains one function to be called. Why do you do this? Because people like OOP. I don't know. All right, so if you're trying to sort, you can pass in the greater functor, and it'll sort it via greater. You can pass in your own if you want to. All right, this is somewhat handy in that if you want to sort your student objects by a certain way, you can just create the function that defines greater than or less than, and then you can pass it over and call .sort, and you don't have to write your own sorting algorithm. And that's all they're going to tell you? Okay. The accumulate function, this is aka summing. But they call it accumulate because you can do plus for the sum, or you can do multiplication for the product. Or you can write your own. How are we doing? I'm assuming you don't need me to do this. There we go. Here's the functor thing I was telling you about. Public, it has to, operator, the function has to be or have this name operator, open close parentheses, and then open parentheses the parameters. This might be confusing, but you are calling, when you call the class, that's when you call this less than or greater than sign, which is effectively passing in this function right here that you've defined at this location. Now the accumulate says that it has to take two parameters and return a parameter of the same type. Other functions or functors may have different parameters here as well as different return types. But for C++, it has to be operator greater than, open parentheses, close parentheses. The square itself. Right, so if you define your own complex, all right, so here's the point of this. You define your own complex class somewhere else. Actually, I think complex is part of the STL. But whatever, let's pretend it's not for a moment. You can push all, or update your vector to have all these complex data types. And then you can call accumulate starting with an initial value of 0. Notice that you had to give it an initial value. And then you can pass in your function that you want to call. Notice that since they templated square sum, this means that the square sum will now work on anything as long as the templated parameter overloads or has plus as well as multiplication overloaded. That way you even can code less if you want to. Okay. There's kind of a lot on this slide. Some of it's beyond the scope of what we're doing here because it's just a bunch of OOP. But do you have any questions on this one? No question. All right, great. Associative containers, beautiful.